In this video we'll cover data binding in WPF, which allows you to easily link UI elements to data sources, saving you time having to update those UI elements manually. Hey guys, and welcome to Azul Coding. To save time, I've gone ahead and set up some of the UI controls we need to demonstrate data binding, and I'll talk you through this in just a moment. All the code in this video is available from the link in the description down below. I'll be writing this in C#, but there's a VB.NET translation available too. Let's first explore the basics of data binding. A simple thing we could do is bind a label to a value of a text box, so that when the user enters something in the text box, that value will appear in a label. I'm using a text box here, which is essentially a label but with more formatting options. We first identify the property that should contain the value. Here it's the text property, and then we can use this notation to specify the element we're linking to, and the property of that element which contains the value. We want to link to the text box value, so we simply provide the name of the text box and the text property which will contain the value. And I don't even need to run the application to test it out, as I can type something in the text box here in the designer, and as you can see the label updates accordingly. There's another way to set up this binding between controls than us in the code behind. When the app initializes, we can create a binding, setting the property and element name of the control that contains the data we want to access. As we saw earlier, this will be the text box and text property. We then apply this binding to the label using the setBinding function. Because data LBL is a run element, we can specify run and then look for the text property. It's worth noting that if you're applying this to a text block, then you need textblock.textProperty, or if it's a label, it'll be label.contentProperty, and so on. We'll then provide another parameter for the binding itself. Let's test it out. I'll remove the binding in the XML code and then run the application. And there we are, the binding has been set up as intended. Now we'll look at how to convert and format values that we've bound. I've added in some new elements to demonstrate how we can format string values through a binding. In the first example, I'm getting the actual width property of the window, which is called main here, and I'm using string format to format that value into a new string. I've added in some text before it, and then I'm using this notation to format the number to one decimal point, including a thousand separated with a comma. The second example formats the value as a currency, and you can also specify a culture using the Convert to Culture option. Because I've specified French here, you can see that the currency has been formatted as euros in the designer. And lastly, I've formatted the current time here as well using HH:MM. It's important to note in this case that because there's no text before the value, we need to add in these empty curly braces to avoid an error. I'll leave a link in the description to the reference documentation for this string format option. I've also got a text box and checkbox here, and I'm going to add a binding on the isChecked property of the checkbox, so that when the user enters a web link in the text box, the checkbox will be ticked. But we'll first need to convert the text box value to a boolean somehow. We can do this by adding in a converter class in the code behind. This converter class should implement the iValueConverter interface. You can do this by hovering over this here and selecting the Implement Interface option in IntelliSense. This will then create the functions we need. The convert function will be called when we're converting the text box value to the checkbox value. This occurs when the user will enter a value into the text box. For this example, we can convert the text box value to a boolean based on whether the value starts with HTTPS. If the value is null for some reason, we can just return false. So we've now converted the value one way, but we also need to convert it back. We can do this in the convertBack function and check the boolean value. If it's true, we'll just add in HTTPS into the text box, and if it's false, we'll pass a blank value. Once we've created the converter, we'll need to build a solution so everything syncs up, and then add a reference to the window resources like so. And we can then add our binding to the isChecked property down here. Let's test it out. And as you can see, the values of the text box and checkbox update in sync. We can also specify that we want the binding to be one way only, so that when we change the checkbox value, the text box won't be affected. We can do that like so and test it out. And then we are interacting with the checkbox, didn't affect the value in the text box this time. Let's look at binding custom classes and deal with updating property values. I've now added in a data grid which will display the values of our custom class, along with a text box that we'll use to edit one of the properties of the class, and a button to remove a data grid entry. In the code behind, I've also added in an observable collection that we'll use as a data source for our data grid item. And further down are some click event handlers, but most importantly we have our custom class, containing name, email and phone number properties. I've added two persons in the constructor, and so all that's left to do is set the item source of the data grid. In the Edit button event handler, we can first check if an item is selected in the data grid and a new name has been entered in the text box. If that's the case, we can then update the name of the selected person item accordingly. For the delete button, we can remove the selected person item like so. Let's see if it works. If I select one of these and delete it, that works as expected. If we were to add a new item after assigning the item source, that would also work. I'll demonstrate this by adding the second item after the item source gets set here. But if I try editing one of these items, the data grid doesn't update with a new name. That's because we need to implement a property changed event handler. We can first modify our person class to implement the iNotifyPropertyChanged interface, using the IntelliSense option again to add in the event. We can then create a helper function to invoke this event and signal that a property has been changed. We lastly need to add in a getter and setter for the property that we need to observe the changes. If you'll be updating all properties, you'll need to do the following steps for every property, but as we'll just be updating the name property for now, I'll just focus on this one. So you'll first need to create a private field that contains the name value behind the scenes, and then when we get the name value, we can return this private field. When we update the name property, we can use the value keyword to get that updated value and apply it to the private field. Don't forget to call our helper function so that the data grid knows it needs to update. Let's test it out again. And there we go, the name updated correctly. If you're looking for an example app that uses bindings, I've created a suite of WPF desktop apps in C# that are all open source. I've also made a language insight built with Eleventy that's 100% free. Check them both out in the description down below. Be sure to leave a like if you enjoyed this video and subscribe to keep up to date with the latest from Zool Coding. Thanks for watching and I'll see you soon.